Air is held inside a non-insulated cylinder using a piston. The mass of piston given is 25 kg and the area is 100 cm square. And stoppers of negligible area as shown in the figure. Now the initial pressure Pi and temperature Ti of air inside the cylinder are 200 kilopascal and 400 degrees Celsius respectively. So the initial pressure and temperature is also given. Now the ambient pressure P infinity and temperature T infinity are 100 kilopascal and 27 degrees Celsius respectively. The temperature of the air inside the cylinder at which the piston will begin to move is what? So in this problem we need to find the temperature of the air inside the cylinder. Okay, so this inside the cylinder we need to find the temperature at which the piston will begin to move. So under the given condition, the piston will move downward only when the total downward pressure is more than or equal to the total upward pressure. Okay, so according to the given condition, this is the piston. Okay, so let's say this is piston and the mass of this piston given is 25 kilogram. Now here the initial temperature and the initial pressure is also given, but we need to find the temperature at which the piston will start to move, right? So that means it will exert a force in the upward direction. Now already we have the atmospheric pressure, that is the ambient pressure and temperature also given in the problem, T infinity and P infinity. This both information is also available. And there is a stopper which is having a negligible mass or area. And the area of cross section is also given here. So let's write here area is equal to 100 centimeter square. Now if we draw the free body diagram of this piston, so there will be self weight of the piston acting, let's say W, in the downward direction, right? That will be equal to mass of piston multiplied by the acceleration due to gravity. And in the upward direction, the air pressure will be acting, right? So in this direction there will be air pressure, and the external pressure, that is the pressure of the environment, will be acting in the downward direction. So this is P infinity. Okay, and this is pressure of air, so let's write PA. Now if we balance the force in vertical direction, we can write from this free body diagram of piston, we can write, so the this force exerted by this pressure inside the cylinder, so PA into area of this piston will be equal to the weight, self weight of the piston, so W, plus the ambient pressure, the force exerted by the atmosphere. So let's write P infinity into A. So we can modify this equation and we can write it as PA is equal to W by A plus P infinity. Okay, we just divided the whole equation by the area. Now this weight is equal to mg. So mass of the piston is given 25 kilogram. The acceleration due to gravity is 9.81 meter per second square divided by the area, that is 100 centimeters, or we can also write 100 into 10 to the power of minus 4 meter square, plus the ambient pressure, that is 100 kilopascal. Okay, so if we calculate, we get the pressure of air, we will get it 100. Sorry, my mistake here. This whole term is in SI unit, so this will be Pascal. We need to convert this term in kilopascal, so we multiply here by 10 to the power of minus 3 in this first term. This is already in kilopascal. Okay, the pressure of air we will get is 124.525 kilopascal. Now according to the problem, the piston is just about to move, right? Because of this air pressure, the piston is just about to move. That means it will undergo a constant volume process. So that is called isochoric process. So let's write isochoric process. Okay, so the gas will undergo isochoric process because the piston is just about to move. That means what? Volume remains constant. Okay. From the ideal gas equation, we can write from the equation, ideal gas equation, PV is equal to mRT. If volume is constant, that means pressure is directly proportional to temperature, right? So let's write here, initial pressure divided by initial temperature will be equal to final pressure divided by final temperature. So here final pressure is PA, right? PA, pressure of the air inside the cylinder. And so for the corresponding temperature, let's write TA. So PI by TI should be equal to PA by TA. Okay, and the PI value and TI value is also given in the problem. Let's see here. So PI is 200 kilopascal and temperature is 400 degrees Celsius. Okay, so initial pressure given is 200 kilopascal divided by 400 degrees Celsius. So 400 plus 273, because we need to convert it into SI unit, right? So SI unit is Kelvin. So if we are converting in Kelvin, we will just add 273 in this, okay, in degrees Celsius. This will be equal to PA. So PA that we have got here, the value of PA is 124.525. So let's write here 124.525 kilopascal. This is also kilopascal, right? And divided by TA. TA will get in Kelvin. So TA will be equal to 419.02 Kelvin. But we need to find this answer in degrees Celsius. So we'll subtract 273 in this and we get the temperature of air for which the piston will start moving. TA will be equal to 146.02 degrees Celsius. Okay, so this will be the temperature of the gas inside the cylinder for which the piston will just start to move. Okay, so such that the complete process is isochoric process. Okay, now let's go back to the problem and fill in the blanks. So the temperature is 146 and 2 decimal place, so 0.02 degrees Celsius. Okay, because we need to find the temperature in degrees Celsius. To get hold on these type of problems, you can refer to the NPTEL course, lecture number 19, Properties of Ideal Gases on Basic Thermodynamics by Professor S.K. Soom of the Department of Mechanical Engineering at IIT Kharagpur.